Okay, so the network is set up. Now let's use this Python script. Basically what this Python script does is it imports Wireshark. So I'm going to run Python 3, run a script that imports Wireshark, creates a variable called capture, that calls this live capture option in Wireshark and captures traffic directly from Ethernet 0. Now there's actually a fantastic application that you can use through your console when checking things in Python, and that's iPython. iPython is a nice interactive shell for Python. Rather than having to use an IDE or integrated development environment on a GUI, you can do something similar directly through the console. Now I'm going to connect the Ubuntu client back to the Ether switch so that this installs properly. So I'm going to say pip3 install iPython. And that's if I can spell right. Looks right. So that's installed. So let's see what we get when we run iPython 3. Notice we are running Python 3.5. Now I made a mistake earlier of installing iPython for Python 2.4. So I want to run iPython 3 because I want to use Python 3 here, not Python 2. So iPython 3 runs Python 3.5.2 and gives us a nice interactive, enhanced Python interface. So what I'll do actually is move this connection back to the Ether switch. This is just a problem in GNS3. If I try and download software through the NAT cloud via the Cisco switch, it's extremely slow. So I want to connect directly to the Ether switch module in GNS3. Okay, so going back to our script, import Wireshark. Notice that works. And then I can say capture equals Wireshark. And notice what happens when I press tab. I get a lot of options here. Capture, config, file capture, live capture, tshark, packet, etc. So if I say live and press tab, notice all the options are available to me. And now I can specify my interface, something like that. And then I could write code or simply paste it in. Notice it's nice and color-coded. So let's say if OSPF in packet, print the OSPF password, and I'll press enter again. Now that's actually running, so it should pick up any OSPF passwords. Notice the OSPF password is OSPF pass. If I go onto the router and I change the password, at the moment it's configured as OSPF pass on this interface. But I could change that. So once again, on the interface, IP, OSPF, authentication, key, Cisco, we should see that the password changes to Cisco dynamically in our script. And there you go. Notice it's done that here. Now, this is through an interactive shell. You may not want to do it that way. Now, this is again an issue with Wireshark. I'm not going to worry too much about it. But notice I'm back in Ubuntu now, basically in the Ubuntu shell. Uname all shows us that we're running Linux, Ubuntu here. What I'm going to do is copy this entire script. So I'm going to say nano ospf.py and paste my script in. So rather than doing it interactively, I've created a script. And what that will allow me to do is use Python 3, OSPF, Py, and run the script. So you could schedule the script to run. Rather than printing the output to the screen, you could save it to a file as an example. So back on my router, I'll change the password or clear the OSPF process so it happens quicker. So process, yes. we should see the output on our script, unless I've done something wrong. Let me go onto the interface, type IP OSPF authentication key, OSPF pass, clear IP OSPF process. Okay, so something's going wrong there. Let me run T-Shark and make sure that we're actually seeing captures. Sometimes in GNS3 things can go wrong. So notice at the moment we're not seeing any traffic. That's a problem. So if I ping the broadcast address, no traffic is being seen. That's probably an issue on GNS3. It's not a script issue. It's a problem in my GNS3 network. That's one of the problems using GNS3 rather than, say, physical equipment for this. Okay, so I'm still having problems. What I'll do is stop my network and start it up again, and let's see if that solves the problem.